Hello, everyone. Um, can you hear me, guys? Hello.
Yes po.
Okay, thank you. So we are only 15 here, so I guess I expect like participation, especially in chat. Okay. Okay, so let's start since it's already how many minutes? 8 minutes past 3 p.m. Okay. So welcome to PHiMO Finals, PHiMO 2023 Finals Review. Um, this is session 1 for secondary 2, and I will be your lecturer for this afternoon. Uh, by the way, I'm Sir Genesis. Hi, guys. So, yes, we can start now with number, with the multiple choice questions, which are 10 questions, right?
Urgencies.
Yes? Hello?
Primary.
What? Hello?
Primary ang nakalagay.
Wait, breakout room? What did I join? Yeah, this is secondary 2A, right? Okay, so anyways, let's start with number 1. Okay, so determine the exact value of square root of AB if A is equal to 8 multiplied to 1 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, and B is equal to 10 raised to 9 minus 9, 8, 7, 6, 5, 4, 3, 2, 1 divided by 5. Okay, so we have these five choices here, which are so long to um, read, read. So let's just proceed to the solution. Okay, so of course we are to find square root of AB. So we multiply A and B under the square root symbol. Okay, and then we are to simplify. Now this one right here will be equal to 1, 2, 3, 4, 5, 6, 7, 9, 0. And here, this becomes 1, 2, 3, 4, 5, 6, 7, 9. Okay, so as you can see, here, simplified. Also for this one, it's already simplified. Now if you'll notice these two actually have the same 8 digits. With the first one having 0. So we can just factor out 10 here in order to get 1, 2, 3, 4, 5, 6, 7, 9. Okay. So after that, after we factored out 10, we already got a perfect square here value and then divided by 5. This one right here, we can just divide 10 divided by 5, which is 2. Which will give us square root of 16 multiplied to 1, 2, 3, 4, 5, 6, 7, 9 squared. Now 16 here is also a perfect square. So we just simplify that. It will give us 4 times 1, 2, 3, 4, 5, 6, 7, 9. Now if you've already gotten this far in the solution, if you look at the choices, we can already get the letter of choice directly, since only C will give us some of a value close to 448. Yeah, it's like 48,000. So here is 49,000. The other values, the other two are just way smaller, while the other two are way larger compared to C. So the answer for question 1 is letter C. There. Here. Okay. Next, we have question 2. Compute the exact value of cube root of 2024 raised to 3 plus 3 multiplied to 2024 minus 3 multiplied to 2024 quantity squared minus 1. Okay, so if you're familiar with special products, yes, this meeting is being recorded. Don't worry. So if you're familiar with special products, we have here we can just express this one into cube root of 2024 cube, while this one right here we have minus 1 cube. And then for the whole expression, you may notice that we have 3's here. So that will just be 3 times 2024 squared, 2024 times 1 squared minus 3 times 2024 squared times 1. Now here, we can just rearrange the second and third term so that we can see the special product more clearly. So that will be cube root of 2024 cube minus 3 times 2024 squared times 1 plus 3 times 2024 times 1 squared minus 1 cube. Now, this special product is actually of the form a cube minus 3a squared b plus 3ab squared minus b cube, which is a special product for the cube of the difference of a minus b. So if you try to look at the values, a is equal to 2024 while b is equal to 1. So what we just need to do now is just substitute. So that will be cube root of 2024 minus 1 raised to 3, which is then simplified into 2023. So the answer for number 2 is 2023. Letter B. Okay, so let's continue with can I make x then just simplify it? Yes, yes, you can actually just make that as x. Then you can have like x cubed minus 3x squared plus 3x and minus 1, which will then simplify into cube root of, I know, it's just x minus 1 raised to 3. Now you can also have that one. But if it's not equal to 1, then you must try to express the two values into two variables. Okay. So that's it for number 2. Let's proceed to number 3. An n-sided polygon has 230 diagonals. Determine the value of n. Okay. So for this one, we just need to recall the formula for the number of diagonals given given a polygon with n sides. So in this case, we have n times n minus 3 over 2, which is the formula for the number of diagonals that is equal to 230. And then we can just solve for n. In this case, we have n times n minus 3, which is equal to 460, which will give us n squared minus 3n is equal to 460. Okay, and then we just need to factor this one. Now, we just need to find two factors of 460 such that their difference will give us 3 or -3. So those two values are just easy to solve because 460 can just be expressed as 23 times 20. So since we have -3 as the coefficient of n, then we can have -23, while the other one is +20. So the factored form for n squared minus 3n minus 460 is n plus 20 multiplied to n minus 23, which is equal to 0. Okay. And then we have this value, n is equal to 23. So the answer for number 3 is letter D. Again, we don't use n is equal to -20 because we don't have negative number of sides. Okay. So let's continue with number 4. Which of the following is the factorization of x raised to 4 plus 1024? Okay. So for this one, what we just need to do is try to look for ways like using special products in order to factor this one. Okay, so here we have x raised to 4 is equal to x squared quantity squared plus 32 squared. Now, since we have two perfect squares here, so a way to kind of try to create, like, let's say, a possible factor for this one is by actually completing this perfect square trinomial. So it's not it's not just always that the given in order for you to complete a perfect square trinomial will be the x squared and the x, and you just have to add the constant. But other times, in order to try to create, I said try because when we're talking about perfect square trinomials, we have two possible values to add when you have, let's say, given x squared and y squared, because you can have positive and negative 2xy in order to create a perfect square trinomial. So in this case, what we did is we tried to add okay, so we tried to add 64x squared. Now, if you try to add 64x squared, then you must also subtract 64x squared in order for the whole or the whole expression to have, of course, its original value. Now, why 64x squared? Because as what I've written earlier, we have 2xy. So here, imagine this being, let's say, a. So we have a squared. This is b squared. Then we must have 2ab. So that will be 2 times 32 times x squared, right? Or, yeah. So, which is equal to 64x squared. So that is how you, now, how you try to complete the perfect square trinomial. Now, in this case, if you look, there are, as I said earlier, we can create a perfect square trinomial using 64x squared and -64x squared. But if we try -64x squared here, then we are again trapped between two perfect, between the sum of two perfect squares. So what we will decide here is we use the positive one so that later we have difference of two squares which we can factor using these special products. As you can see here, we have x squared plus 64x squared plus 32 squared minus 64x squared. Now this right here becomes a perfect square trinomial. This perfect square trinomial can be expressed as x squared plus 32 quantity squared. While in this one, we have minus 64x squared. So a perfect square, so difference of two squares. Now, when we recall difference of two squares, you can just have, I'll just use another variable. So a squared minus b squared will just be a plus b multiplied to a minus b. So in this case, we have, yeah, we must express, of course, we must look for a and b, right? So this is a. For 64x squared, we get the square root of that. You will have 8x and then quantity squared. So this will be our a, this will be our b, and then applying the difference of two squares. We have x squared plus 32. So you can see x squared plus 32 plus x, and x squared plus 32 minus x. Now, arranging these two, we have x squared plus x plus 32 multiplied to x squared minus 8x plus 32, or x squared minus 8x plus 32 multiplied to x squared plus 8x plus 32. So that will be the factored form for x raised to 4 plus 1024. So if you match this one with any of the choices, you will have D as your final answer. X squared minus 8x plus 32 multiplied to x squared plus 8x plus 32. Okay. So next one. Number 5. At what time between 3 and 4 a.m. will the hands of a clock form a right triangle? Okay. So if you think about it, 3 a.m., right? 3 a.m. that's already forming a right triangle. However, it says here between 3 a.m. and 4 a.m. So we must exclude that one. Here we will use the clock angle formula, which is theta is equal to absolute value of 30h minus 11 over 2m. Okay. Now, since it is a right triangle, we have 90 is equal to absolute value of 30 multiplied to 3 because it's between 3 a.m. So the hours here is 3. While m, we still have to solve for m. Okay. So that will be, okay. So here, if we try to simplify, first, of course, is positive, right? However, when you try to get 90 is equal to 90 minus 11 over 2m, then your m will give a value of 0, which is, of course, saying that the time that you can form a right triangle is 3 a.m. But as what I've said earlier, it must be between 3 a.m. and 4 a.m. So m should be greater than 0. So in that case, we will choose the value negative 90. So negative 90 is equal to 90 minus 11 over 2m. So solving for m, you will have 180, 360 over 11, right? Which will be equal to 32 and 8/11. So that means that at 3:32, 8/11 in the morning, the hands of a clock form a right triangle. So the answer is B. Okay. Next, number 6. If m is not equal to 4 and m cubed is equal to 64, then what is the value of m plus 16 over m plus 2020? Okay. So for this one, we have m cubed minus 64 is equal to 0, right? When we manipulate this one. If we try to use the special product and factoring this one, difference of two cubes, you will obtain m minus 4 multiplied to m squared plus 4m plus 16 is equal to 0. Now, using zero product property of real numbers, it can either be m minus 4 is equal to 0 or m squared plus 4m plus 16 is equal to 0, or both of them equal to 0. However, m minus 4 is equal to 0 is not applicable since it already says in the problem m is not equal to 4. So we focus on m squared plus 4m plus 16 is equal to 0. Now, what will we do in order to have m plus 16 over m? So we divide both sides by m. We already know that m is not equal to 0. So we can divide both sides by m. That means you will obtain m plus 4 plus 16 over m is equal to 0. As you can see, we already have m and 16 over m. Okay, so m plus 16 over m is equal to negative 4. But the problem asks for plus 2020. So you just add both sides by 2020 and you will get negative 4 plus 2020, which is equal to 2016. So the answer for this one is letter C. Okay. Number 7. The ratio of the three interior angles of a triangle is 7 is to 10 is to 13. What is the measure of the second largest interior angle in degrees? Okay. So what we know here is that we can express the sum of interior angles as 7x plus 10x plus 13x, knowing that the sum of the interior angles of a triangle is equal to 180. Okay, we then have to solve for x. So that will be 30x is equal to 180 or x is equal to 6. The question asks for the second largest interior angle. So we have 10x is equal to 10 times 6, which is equal to 60. So the answer for number 7 is letter A. So this one is easy. Okay. So next one for question 8. How many integer value or values of x is or are there such that 4x minus 13 is greater than negative 19 but less than 23? So this one is a linear inequality. So what we just do here is to solve for x in the middle. So here we have 4x minus 13. So the first step here would be by eliminating negative 13. So how do we do that? We add 13 to the whole inequality. So by adding 13, you will have negative 19 plus 13, which is equal to negative 6. Also for the right-hand side, we have 23 plus 13, which is equal to 36. Now we are left with this inequality. Since we have 4x, we need to divide both sides by 4. So obtaining x is greater than negative 6 over 4, but less than 36 over 4. Simplifying, it will give you x is greater than negative 1 and 1/2, but less than 9. Now the question asks for how many integer values. So we have from negative 1, because it says here it should be greater than negative 1 and 1/2. So the negative integer greater than negative 1 and 1/2 is negative 1. So that will be included. Also 0 is included here. Of course, since it says less than 9, so we only count up to 8. So here we have negative 1 to 8. So we have all integers from -1 to 8 as values for x. Hence, we have 10 integers. So that is 1 from -1, 1 from 0, and 8 from 1 to 8. So that will be 1 plus 1 plus 8, which is equal to 10. So there are 10 integer values here. So the answer is letter E. Number 9. In a quadratic equation, if the sum and product of the roots are 3 square root of 5 and 9 respectively, then what is the absolute value of the difference of the roots? Okay, so what we just do here is try to express the question into algebraic expression or equations. So here we have let A and B be the roots of a quadratic equation. It says that the sum and product of the roots. So when we have sum, that will just be A plus B is equal to 3 square root of 5. And for the product, we have AB is equal to 9. The question asked was the absolute value of the difference of A and B. So we have, of course, since we need A minus B, so in order to transition from A plus B to A minus B, we try to get the square of A plus B. So here, we have A plus B quantity squared is equal to A squared plus 2AB plus B squared. Now, knowing that A, we need A minus B, right? If you try to square A minus B, that will be A squared minus 2AB plus B squared. So what our goal here is to transform this plus 2A into negative 2AB. So that will just be subtracting negative 4AB from both sides of the equation. So subtracting 4AB from both sides of the equation will give us A plus B quantity squared minus 4AB is equal to A squared minus 2AB plus B squared, which we can then express as A minus B quantity squared. Okay, now substituting the values, we have A plus B squared, so 3 squared of 5 quantity squared, minus 4AB, so minus 4 times 9, that will be A minus B quantity squared. Now, we have 3 square root of 5 quantity squared, that will be 9 times 5, which is 45. 4 times 9, which is 36. So we have 45 minus 36 is equal to 9. Now, getting the square root of both of the sides of the equation, we have the absolute value of A minus B is equal to 3. Now, actually, that is important here because if without that, I think you will have a negative difference, or you might as well get 3 as. So the answer for number 9 is letter C, 3. Okay, number 10. Determine the exact value of 3 plus 54 over 3 plus 54 over 3 plus 54, and so on. Okay, so this one is quite easy because if you try to let x be this expression, given expression, this right here, the denominator right here, can also be expressed as x, right? Because that is the same expression as x itself. So that will be x is equal to 3 plus 54 over x. Now we are to solve for the value of x. So multiplying x to both sides of the equation, you will have x squared is equal to 3x plus 54. Manipulating the equation and factoring this value or getting the value of x, we have x minus 9 multiplied to x plus 6 is equal to 0. So we have negative 6 and 9. Now take note, if you look at the whole expression, right? This one is a positive value, and also this will give you a positive value because all of the expressions here are positive. So that means that x is greater than 0. So since x is greater than 0, then of course x will be equal to 9, not negative 6. So negative 6 here is just not applicable for number 10. So the answer for number 10 is letter E. That is 9. Okay. Okay. Any questions for the multiple choice questions? If you have questions, please type or ask in the chat box. If you have no questions, please type none in the chat box so that I can see those who have questions and those who have none. Let me drink some water first. How about the others? Okay. So if there are no questions, I guess we can proceed. Oh, by the way, you may also use your mic in order to ask questions, okay? If you are tired or not in the mood to type. Okay. So let's proceed to the what's close-ended? I think. Yeah. Anyways, number 11 to 30. Number 11. Find the exact value of cube root of 20 plus 14 square root of 2 plus cube root of 20 minus 14 square root of 2. Okay, so at first glance, it's actually very tiring to answer. Alright, it's kind of I don't know. Anyways, so the way we answer this is, since we need to find the exact value of the whole expression, the first thing that we can do is try to let x be this expression, just like what we did in the previous number. So we have x is equal to this one, cube root, the given expression. The next thing that we will do is to raise both sides to the power of 3. That way, we can see, or that way we can have, or we can get rid of cube root here for these two expressions. So we have x cubed is equal to, okay, this one. So since we have 20 plus 14 square root of 2 and 20 minus 14 square root of 2, right, for this one, now we are left with the other two expressions. If you remember earlier, if we have a plus b raised to 3, that will be a cube plus 3a squared, b plus 3ab squared plus b cubed. So as you can see, this is already a cube and this is already b cubed. So we'll just follow this one. So we have 3 multiplied to cube root of 20 plus 14 square root of 2 squared multiplied to cube root of 20 minus 14 square root of 2, and for this one plus 3 multiplied to cube root of 20 plus 14 square root of 2 multiplied to cube root of 20 minus 14 square root of 2 squared. Now it might actually seem very tiring at first. However, it's not what do you call this? It's not necessary to simplify that one. So what you can just do, at first is of course simplify these two, because these are the ones that can be simplified earlier. So you can remove 14 square root of 2 and you will have 20 plus 20, which is 40. Now the next thing here is look for common factors between these two expressions. So as you can see, we have 40, x cubed is equal to 40. And then our common factors for these two will be 3. Okay. We have cube root of 20 plus 14 square root of 2. And we have cube root of 20 minus 14 square root of 2. Right? So we have this one, this expression right here. Now, if we try to factor this 3 out from the two expressions, we will be left with one copy of cube root of 20 plus 14 square root of 2 plus one copy of cube root of 20 minus 14 square root of 2. Now, here, you will see that this expression, when multiplied, right, since they have the same index, then we can multiply the radicands. And if you look at the radicands, they are possible factors of difference of two squares. So we can apply the special product there. Now for this two, what's this? This is actually the given x, right? This is x is equal to cube root plus 20, right? These are the expression, or these are the expressions that is needed for x. So if you try to simplify this one, you will have, wait, is it not showing still? There. So we have x cubed is equal to 40 plus 3 multiplied to, so we still haven't simplified this one, okay. And then for this one, we have x. Now, if you simplify that, in the next line, you will have x cubed is equal to 40 plus, here, we have 3x. And then difference of two squares. So cube root of 20 squared, 400, minus 14 square root of 2 squared. So that will be 196 times 2, which is 392, which will give us x cubed is equal to 40 plus 3x multiplied to cube root of 8. We already know how to get cube root of 8. That will just be 2. And then we try to solve for x. This becomes x cubed is equal to 40 plus 6x, which is equal to x cubed minus 6x minus 40. Okay, so how do we solve this? Factor. So that will be x minus 4 multiplied to x squared plus 4x plus 10 is equal to 0. Well, this one, we can't get factors here, but we have one integer here that is equal to x. So the answer will just be x is equal to 4. So that is number 11. X is equal to 4. Next, number 12. Okay, determine the area of the given square as shown below. Well, for this one, it might be confusing at first, but you can actually try to reflect this one. When you try to reflect FE here, right, that will just form somehow a rectangle for this one, which also reflects CF. So this is actually 15, right? So we have 20 plus 15, so that will be 35. Now for something like, since the question needs to find the area, we can just create this triangle, right? This one. Okay, so that will just be, yeah, finding the diagonal. How do we solve for a CA? We already have a right triangle. So we just need Pythagorean theorem. So where we have 20 plus 15 has one side, and we have 5, which is the reflected EF to C. Okay. So that will just be 35 squared plus 5 squared, which is equal to 1 to 50. So our diagonal is actually 1 to 50. Okay, sir, so we have the diagonal, so we can solve for the side, right? And then get the area. But there is also another formula for the area of the square. That is 1/2 d squared. So instead of solving for the side and then just squaring it, you can actually have 1/2 d squared. So 1/2 d squared will just be equal to 1/2 multiplied to d squared right here, which you solved earlier, which is 1 to 50. That will just be equal to 625. So the answer for number 12 is 625. Okay, next question. Question 13. If x and y are positive numbers such that x squared plus y squared is equal to 15 and xy is equal to 17, find x plus y. For this one, it's the given is actually giving away most of the info that you need in order to think of the process, because this right here, x squared plus y squared, and you have xy, and since you need to find x plus y, that will just be enough in order to substitute into a perfect square trinomial, right? So if you just get the perfect square, plus y, quantity squared, which is equal to x squared plus 2xy plus y squared, we can just then substitute the values. So that will just be x squared plus y squared, which is 15, and you have 2xy, so 2 times 17, and then that will give you 49. So it's not yet the answer because we still need to get the square root. Now, getting the square root, you will have x plus y is equal to square root of 49, which will give you 7. So the first question is, why is it not negative? Because x and y are positive. So if both are positive and you are to solve for the sum, then the sum must also be positive. So in this case, we have 7. So that is number 13. The answer is 7. Okay, let's proceed with number 14. Given that 9x squared plus 4x squared is equal to 6, determine the value of 27x cubed plus 8x cubed. Okay, so for this one, what we just need is to factor 27x cubed plus 8x cubed. So this one right here is sum of cubes, right? So how do you solve for sum of cubes? The same, a cubed plus b cubed, right? So what is a? Get the cube root, so you have 3x. Get the cube root, so you have 2 plus 2 over x. And then for this one, get the square of 3x, 9x squared. Get the square of 2 over x, 4x squared, and then get the product. And since we are talking about sum of cubes, then the middle term should have negative right here. So that will be 3x plus 2 over x multiplied to 9x squared minus 6 plus 4x, 4 over x squared. Okay, now it says here 9x squared plus 4 over x squared is equal to 6, which is this one. So if we substitute 6 there, that will just be 3x plus 2 over x multiplied to 6 minus 6, which will give us, this becomes 0. So if that is 0, then the product will be 0. So the answer for number 14 is 0. Okay. So next one. number 15. If a, b, and c are positive integers and 3a plus 5b is equal to 5b is equal to 7c, what is the smallest possible value of a plus b plus c? So what I will do here is I can actually express the two variables using um, one. So I need to express the other variables into a one variable in order to get the let's say relationship. Okay, so for this one, we use 3a is equal to 5b. Now manipulating that by dividing 5 uh, from both sides of the equation, we have b is equal to 3a over 5 or 3/5 a. Now for 3a is equal to 7c, dividing both sides by 7 will give us c is equal to 3 over 7a. So as you can see, we have expressed b and c in terms of a. Now there is a purpose there because if you try to substitute that to the equation, or we can just try to express it as a ratio, that will be a is to 3/5 a is to 3 over 7a. Now, if we try to divide a and multiply by the least common denominator, we can actually express that as 35a is to 21a is to 15a, or just 35 is to 21 is to 15. Okay. Now, oh yeah. Okay, so there is a reason why. Because it says here what is the smallest possible value. And if you think about the smallest, and since both a, b, and c are positive integers, the smallest that you can give for a value here for a is of course 1. So then we can have 35 is to 21 is to 15. So you can use that as values for a, b, and c, which will give you a plus b plus c is equal to 35 plus 21 plus 15, which is equal to 71. So the answer for 15 is 71. So there are other ways to solve this, like getting the what do you call this? Getting the LCD of 3, 5, and 7. That will be 105. And then dividing by the uh this one, their what do you call this coefficients. So that will be 105, which is the LCD, divided by 3, 105 divided by 5, and 105 divided by 7, which will still give you 35, 21, and 15, which when you add the 3 will give you 71 still. Okay. So, okay, so break time. So since it's break time, any questions before the break? Any questions from question 11 to 15? If you have no questions, type none. However, if you have questions, please ask. Okay. How about the others? We are 21 here, and I only saw like, okay. Since there are no more questions, I guess we can take our break. So since it's 3:57, I expect you to be back at 4:07 p.m. Okay. So type 4:07 p.m. PST. Type ready rather. Okay, so see you 10 minutes after. Bye, guys. How about the others? Following instructions. Let's go so that we can continue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. More than half. 8, okay. So, okay. Since most of you are ready now, okay, I'm seeing lots of replies. Let's proceed. Let's continue with the other half. Number 16. Okay. So the surface areas of two cubes, one of which has an edge 15 centimeters longer than the second one, differs by 3,870 square centimeters. Calculate the length of the side of the smaller cube. Okay. So in this, for this one, recalling the formula for the surface area of two cubes, we have 6 multiplied by side square or 6 side square. So that will be, okay, so for this one, since we are to compare or we are to subtract two surface areas, what we can do is we can let one side length be s sub 1. So for this one, s sub 1 is the side length for the smaller cube, which means that the other cube will have s sub 1 plus 15. Right? So in this case, surface area is 6 side squared minus 6 s sub 1 quantity squared is equal to 3,870. So as you can see, we have s sub 1 plus 15 for the bigger cube. Okay. Now, to make this easier, we can just divide by 6 first, just to make the value 3,870 even smaller. So that will be s sub 1 plus 15 quantity squared minus s sub 1 squared is equal to 645. So again, this is a difference of two squares, right? So we can, oh yeah, or you can just simplify rather, but you can actually use difference of two squares. That will create like, yeah, you can just skip the having s of 1 square. But then again, you can just simplify and then just eliminate this one in order to get s of 1, which is 30 s of 1 plus 225 is equal to 645. Now, solving for s of 1, because it says here, this is actually beneficial for us because it will already give us the length of the smaller, the side length of the smaller cube, which is s sub 1. So that will be 30 s sub 1 is equal to 645 minus 225. Dividing both sides by 30 will give us s sub 1 is equal to 14. So that means that the answer for 16 is just 14. So the side length of the smaller cube is 14, while the other one will have 14 plus 15, which is 29. Okay. So that's it for 16. For 17, find the number of different words with or without meaning that can be formed with the letters of the word attempt, such that the vowels are always together. Okay, so for this one, vowels are always together, right? So what can we do? We can collect all the vowels first and then create a group. So what are the vowels here? The vowels are A and E. So we have one group already containing two elements or two letters. So that means that if this becomes one group, how many elements um are to be arranged? So that will be one. We have 2, 3, 4, 5, 6. So we have 6, right? So 6 letters or groups to be arranged, that will just be in this you get the linear permutation, that will be 6 factorial. However, if you look at the word, we have 3 letters that are identical. We have 3 T's. So you divide 6 factorial by 3 factorial. So that will be 6 factorial divided by 3 factorial. Now, we are still not done, because even though we have arranged all of this, take note that A and E are in a group. That means that there is they have their own possible arrangements as well. So if you're thinking about AE, you can have AE and EA, or just 2 factorial. So that will be 6 factorial over 3 factorial multiplied by 2 factorial. That will be 2 factorial, but you can just multiply by 2 because there are 2 letters only, or 2 vowels. So simplifying that one, you will have 6 times 5 times 4 times 2. Because if you simplify 6 factorial divided by 3 factorial, you can eliminate 3 and you will be left, 3 factorial, and you will be left with 6 times 5 times 4. And then you have times 2. Now simplifying this one, you have 30 times 8. That will give you 240. So the answer for this one is 240. So that's it for 17. Okay, so let's proceed to number 18. A triangle has side lengths of 24, 45, and 51. What is the diameter of the circle that can be inscribed in it? So, which means we need to find, of course, first the in radius. Right? So, what is the in radius? So, it is a radius. It is the radius of the in circle. So the circle that can be inscribed inside a triangle. So something like this. If you have, let's say, a given triangle, then the in circle will be something like this. Um, mm, Something like that. So the in radius is, of course, the radius of this circle. Alright. Okay. So the question asks for the diameter. There are 2 ways in which we can get the in radius. So 2 ways, because there are actually 2 cases. If the given is a right triangle, then we can just use the formula. So the formula will just be the radius, or the in radius will just be equal to A plus B minus C over 2, where C is the longest. C is the hypotenuse. Okay. So that is the if the given is a right triangle. Uh, right triangle. However, if it is not a right triangle, so I'm just gonna write it here. If it is not a right triangle, then the formula will just be R is equal to area of the triangle divided by the semi-perimeter of the triangle. So that is how you get the um in radius. Now for this one, for the second one, not a right triangle, it's not actually limited to not a right triangle. This is actually the general formula. So it's just commonly used when it is not a right triangle, because of course if you are to choose between the two um formulas, if the given is a right triangle, then you can just use this directly. However, for this one, this is the general formula. for the in radius. So how do you get the area of the triangle? Just use Heron's formula, because by using Heron's formula, you can also get the semi-perimeter, at which you can use for dividing here, because you have divided by S. Okay, so first, if you look at the given, that is somehow familiar, because that is actually a Pythagorean triple. Now, how do you determine if the given is a right triangle? If it uh if it if it follows the Pythagorean theorem, right, then it is a Pythagorean triple. And if it is a Pythagorean triple, then if you were to use it as sides of a triangle, then that triangle will automatically be a right triangle. Okay. So 24, 45, and 51 is a Pythagorean triple, which means that it is a right triangle. So you can just use this one. So R is equal to 24 plus 45 minus 51 divided by 2 is equal to 9. So that is still the in radius. The question asks for the diameter. So you can just multiply that by 2 and you will get 18. Okay. Now, if you want to verify if the general formula works, then of course, I can show you like right now. So in order to do that, you need to solve for, of course, S first, right? So S will just be 24 plus 45 plus 51. So semi-perimeter, so half of the perimeter divided by 2, that will just be 96. 96 divided by 96 divided by 2 is 48. 48, so 60. I think this is 60. Okay, so is that 60? Yes. So if S is equal to 60, then the in radius formula will just be um, square root of Heron's formula, right? So Heron's formula is S 60 multiplied to 60 minus 24 multiplied to 60 minus 45 multiplied to 60 minus 51. And then you divide that by the semi-perimeter, which is 60. Okay, so R will just be equal to the square root of 60. Oh, wait, let me use a line tool for that one because that vinculum is so clunky. Okay, so that will be 60, and then 60 minus 24 is 36. 60 minus 45 is 15, and 60 minus 51 is 9 divided by 60. Okay, so simplifying, you have here 60 is actually 4 times 15. So that will be 4 times 15, and then you have another 15, so that creates a perfect square. 36 is a perfect square, and 9 is also a perfect square. So we can simplify that later easily. Divided by 60. So that will be 2 times 15 times 6 times 3 divided by 60. And then what you can do here is 15. So you will be left with 4. 4 divided by 2 divided by 2. So that you will have 3. So R is equal to 9. So since R is equal to 9, then the diameter is equal to 18. Did we get the same answer? Yeah, we get the same answer. So you can use both of the formulas. Okay, so if you just want to, if you are unsure that the given is a Pythagorean triple, then you can just use the general formula. However, if there is a chance that it is a right triangle, then you have to choose the other one because that is much easier. Okay, or this one rather. The okay, so let's. The answer is 18. So let's proceed to 19. If a plus b plus c plus d is equal to 30 and all of them are integers not less than 5, find the number of possible solution sets. Okay, so for this one, what we'll just do is, of course, it says not less than 5, right? So that must mean that A is greater than or equal to 5, B is greater than or equal to 5, C is greater than or equal to 5, and D is greater than or equal to 5. Okay, so with that in mind, we can just let A sub 1 be equal to A minus 5. Now, we let A sub 1 here because what we want is to use the um, stars and bars formula, like directly, n plus k minus 1, choose k minus 1. Now, for that one, we need greater than or equal to 0 because that formula is used for non-negative. Or if you think about it, that is used in order to count the number of distributions such that um, all of the boxes are empty, and that there is a chance that one of the box are left empty as well. So here we have a sub 1 is equal to a minus 5. So this way we've subtracted 5 for this inequality just to show that it is greater than or equal to 0. We can use that for, or we can apply that to all of the variables. So you have a sub 1 to d sub 1, which are all greater than or equal to 0. Now, yeah, or you can just do that one. But later I will show you how you will just do that. But this one, this will teach you what is the basic like idea for number 19, or this. So for this one, of course, a plus b plus c plus d is equal to 30. This is the given, right? So what we need is we need to apply a sub 1 here. So that is why we have a sub 1 plus 5 until d sub 1 plus 5. So where did we get plus 5? By manipulating this equation. Okay. So by manipulating that, so you have plus 5 plus 5 plus 5 plus 5. And then if you try to simplify this one, you will have a sub 1 plus b sub 1 plus c sub 1 plus d sub 1. That is equal to 30 minus 20, which is equal to 10. Now, you are seeing four non-empty, four, let's say, containers that are non-negative. I mean, yeah, non-negative, greater than or equal to 0, which must have 10 objects inside it, or 10 values is equal to 10. Now, if you try to use the stars and bars formula, we have 10 plus 4 because we have 10, and n is equal to 10, k is equal to 4, and yeah, 10 plus 4 minus 1, choose 4 minus 1, which is equal to 13, choose 3, which when simplified is equal to 286. Okay, now here, this is where the, let's say, idea for the, let's say, what do you call this, convention starts. This one. If you look closely, for the value 30 on the right-hand side, you're actually subtracting 5 from each of the containers. Now, think of it this way. If you have, let's say, 30 objects and you want to distribute, okay, I'll just write it here, or I'll just illustrate. If you have A, B, wait, let me just get rid of the text so that I can illustrate it better. Sorry, I'm quite lagging. Okay, so think of it this way: this is A, this is B, this is C, and this is D, right? And then of course we have 30 objects that are to be distributed for these four um boxes. Now it says here that all of them are not less than 5. So that means that if you try to think of this as, let's say, if for this application, then that means that all of the boxes must have greater than or equal to 5. So how will we do that? How will we do that in such a way that we can apply the stars and bars? So we must distribute first 5 for each of the box. That way, our boxes will be or will feel as if they are all empty because we are already satisfied this one. Even if you can not distribute an object here, it is fine because we are already done with the condition. So that way, if you have 30 objects and you are to distribute 5 from each, then of course your total objects after will just be 30 minus 5 times 4, right? So that will be the total number of objects, which of course is equal to 10, but yeah, this is it. Now, using stars and bars, because you can already, this is already n. So n plus 4, which is k, minus 1, choose 4, minus 1. So that will just give you the same 13, choose 3. Okay, so somehow, the general formula is kind of like n plus k, minus 1, k minus 1, plus, I know, wait, it's not something like that. It's n minus mk plus k minus 1. Choose k minus 1 if all of the objects, let's say a sub 1 until a sub, I don't know how many objects, a sub p will be greater than or equal to m. Okay, so that is somehow the like general. If they are, if the restrictions are all the same. But you can also do this, like let's say if it is specific, like if A is greater than 5, B is greater than or equal to 3, you can just distribute the um enough value and then just use stars and bars. I hope they will give us that kind of problem, so you will see how the application of stars and bars work for those other problems. But for now, this is how you solve number 19. Okay, so let's proceed to the next slide, which is number 20. The equation x squared minus the quantity m minus 8 times x plus m is equal to 0 has real roots. Okay, if m is a real number greater than 3, then what is the minimum value of m? Okay, so first, it says real roots, has real roots. So what does it imply? It gives us, let's say, it gives us a hint that we are to use the discriminant. So what is the discriminant? So the discriminant is the expression under the square root symbol, or it is the radicand in the quadratic formula, which is b squared minus 4ac. And of course, it tells us the nature of the roots. Now, if it is greater than 0, it will give you 2 real roots. If it is 0, then it will only give you 1 real root, but multiplicity 2. If it is less than 0, then it will give you 2 imaginary roots or has no real roots. So for this case, it only says has real roots. So there is a chance that it might have 1 or it might have 2. So in this case, we are to use greater than or equal to 0. Now, substituting these expressions here, so for B, you will have negative of m minus 8, quantity squared, minus 4. So A here will just be 1, which is the coefficient of x squared. And C here will be m. So that is greater than or equal to 0. So we have here m squared minus 16m plus 64 minus 4m is greater than or equal to 0. So we have m squared minus 20m plus 64, which is greater than or equal to 0. So we have two values here, or we have two factors, m minus 4 multiplied to m minus 16, which is greater than or equal to 0. And if you were to solve for the values of m, you will have m is less than or equal to 14, and m is greater than or equal to 16. So a quick recap here on how to solve for the values of an inequality is that pick those values that will give you 0. So let's say, for example, m minus 4 is equal to 0 and m minus 16 is equal to 0. Now, those values you can use as critical points. So if you were to draw a line there, you can have 4 and you can have 16. The next thing here would be choosing a test value. So a test value is, of course, a value from your regions. So in this case, you have 3, you have 5, and you have 17. So how do you check if what regions here are the solution sets? Like so here we have 3, right? If m is equal to 3, then of course this is negative. This is also negative because 4 and 16 are greater than 3. So negative and negative, if you multiply two negative values, then that is a positive value. So this is included. So this region is included as a solution set. Next, how about 5? 5 minus 4 is 1. 5 minus 16 is negative. 1 times a negative number is, of course, negative. So this is excluded. For 17, 17 minus 4 is positive. 17 minus 16 is 1. 1 times positive is positive. So this is also included. So there are two solution sets here. We have m is less than 4 and m is greater than m is less than or equal to 4 and m is greater than or equal to 16. Now, since the question says m is a real number greater than 3. So greater than 3, what is the minimum value of m? So since m is greater than 3, then the minimum value of m is actually 4. So I think the thing here is an integer greater than 3. I think this can be changed to an integer greater than 3. Because if we are just to talk about real numbers, then you can have 3.5, right, rather than 4. So yeah, we can use that as integer. So the answer for 20 is 4. Okay. Number 21. Determine the maximum possible area of a sector of a circle given that its perimeter is 32. Okay, here, so this is one already a fact, like it's already established that the maximum area of a sector can be obtained when the radius is 1/4 the perimeter of a sector. So you should take note of this one. So here we have P is equal to 2R. So the perimeter, of course, of a sector, let's say something like this one, okay, will consist of 2R, right, 2 radius, and of course the arc, intercepted arc, which is 2 pi r, and then multiplied by theta over 360. So this theta here is the angle. Okay, now you can manipulate this, and you will have P minus 2R over 2 is equal to theta over 360 multiplied to pi r. And then the area will just be theta over 360 times pi r squared. And since we already have this value here, then we can just substitute p minus 2r over 2 to the formula of the area, which will give us p minus 2r over 2 multiplied by r. And now we can use this one when r is equal to 1/4 of the perimeter. So substituting r by p over 4, that will be a is equal to p minus 2 multiplied to p over 4 divided by 2 multiplied to p over 4, which gives us p squared minus 16 or p minus 4 quantity squared. So you can use both. Now we have maximum area will just be p squared over 16 or p minus 4 quantity squared, which is equal to the given perimeter 32. 32 divided by 4 quantity squared, that will be 8 squared or 64. So the answer for number 21 is 64. Okay, so let's move on to number 22. It is known that x and y are integers, and x multiplied to x plus 1, y plus 1 plus y multiplied to x plus 1 is equal to 2022 plus xy. Determine the number of possible solutions for x and y. Excuse me. So here, what we can do is get rid of this one. So you're left with xy plus x plus y is equal to 2022. Now, since we are to solve for x and y, what you can please um, familiarize this form. If you have xy plus x plus y plus 1, you can actually factor that as x plus 1 multiplied to y plus 1. Okay, so something like that. So that means that if I were to add 1 to both sides of this equation, I can already factor out xy plus x plus y plus 1, which will give us x plus 1 multiplied to y plus 1 is equal to 2023. Now, since we are talking about integers, right, x and y as integers, then what we can do is just count the number of factors for 2023. So note that 2023 is equal to 7 times 17 squared. So that means that the total number of possible solutions or total number of factors will just be 2, because of course we can have x and y as negative values. So that will be 2 multiplied to 1 plus 1. That is because you will just get the exponents and then add 1 in order to get the number of positive factors. So this is actually the formula for the positive factors. That will be 1 plus 1 multiplied to 2 plus 1. So that is equal to 2 times 3, which is equal to 12. So there are 12 possible solutions for x and y for number 22. So the answer is 12. So you can just get the factors, right? Because this is factored. Okay. Number 23. How many ways are there to choose 1 manager, 3 associates, and 5 staffs among 12 people? Okay, so this is just easy. So what you can just do is you choose 1 manager among 12 people, that will just be 12 choose 1, right? So we will be left with 11. So you choose 3 associates from 11 people, that will give you 11 choose 3. Now, we will be left with 8. Now, for the remaining 8, you choose 5 staffs from this 8. and that will give you 8 choose 5. So just multiply this one, and you will get 12 times 165 times 56, which is equal to 110,880. Okay, so sir, a question. Will it make any difference if I pick, let's say, 3 associates first, and then let's say 5 staffs and 1 manager? Actually, it won't make a difference. So try it yourself, guys. So you can have 12 choose 5 multiplied to 7 choose 3 multiplied to 4 choose 1. And that will still give you the same answer, 110,880. So you can try it out. Okay. So next, we have number 24. Determine the total number of combinations in arranging 3 different pairs of couples in a circular table on the condition that each couple is not allowed to sit beside one another. Okay. So first question is, how do we arrange the 3 couples in a circular manner? So that will just be using the circular permutation, which is n minus 1 factorial. Right. So for linear, if we're talking about arranging in a line, then that will be n factorial. However, if it is in a circular manner, or somewhat in a circular manner, then it is n minus 1 factorial. So here, that will just be 3 times 2, because we have 6, we have 3 pairs. So 3 times 2 minus 1 factorial, that is equal to 5 factorial, is equal to 120. Now the number of arrangements such that each couple sit beside one another. So if you think about pairing or creating them as one group, right? So you have 3 groups. So arranging 3 groups in a circular manner, that will be 3 minus 1 factorial. Now we have 2 ways to arrange the couple, right? 2 ways, so they can just switch with one another. So that will be 2 times 2 times 2, or just 2 cubed. So if you simplify that one, that will be equal to 16. So hence, in order to count such the arrangement such that no each couple is not allowed to sit beside one another, then you can just have 120 minus 16. So the concept for 24 is like complement, getting the complement. So you have 120 minus 16, which is equal to 104. Okay, so let's proceed to 25. A coin is tossed 11 times. Yeah, it's tossed 11 times. So determine the probability that the results of the 11 tosses contains exactly 7 heads. Okay, so what you can use here is binomial distribution, or binomial distribution. So the formula for this one will just be, let's say we have n, right? N number of an event occurring, and then let p be the what do you call this? The favorable outcomes, number of favorable outcomes, and q, or this will be p such that favorable outcomes, number of favorable outcomes. So the formula will just be n choose p multiplied to, okay, so what I forgot the probability here. I should have read, what should I write here? Like Okay, so we have, what letter should I use? I could just use A. So A is the probability of it happening, right? Of it happening, and then A raised to P multiplied to 1 minus A, because the total probability is 1, you have 1 minus A, and then you have N minus P. So if we were to, let's say, reflect this on the problem, so the probability of getting 7 heads out of 11 tosses. So our number of favorable outcomes should be 7 heads. So P is equal to 7. So out of 11 tosses, so N. So you have 11, choose 7, multiplied. So A is the chance of happening that favorable outcome. So in this case, we need heads. So since it is a coin toss, then the probability of getting a head is 1/2. So A is 1/2, and then raised to P multiplied to 1 minus A. So 1 minus 1/2 raised to 11 minus 7, or 4. Okay. So simplifying that one, you will have 11 to 7 is 330. For this one, since uh, both of these expressions here has the same base, because 1 minus 1/2 is still 1/2, then you can just add their exponents. So 1/2 raised to 11 on loss of exponents. Okay, and then simplify. So 2 raised to 11 is 2048. Now that will be 330 over 2048, which can be simplified into 165 over 1024. So that is our final answer for number 25. Okay, number 26. If n is a 4-digit palindrome number, how many n are divisible by 6? Okay, so first one, let n be a palindrome. So let's say A, B, B, A. Since n is divisible by 6, then A must be even, right? So n must also be divisible by 3, which means that the sum of the digits must be divisible by 3. So if you think about it, you have A. A can be 2, 4, 6, and 8. However, so if A is equal to 2, then you have your sum 4 plus 2B, right? So 4 plus 2B must be divisible by 6. So you can only have 1, because 2 times 1 is 2. 2 plus 4 is 6. Yeah, it must be divisible by 3 rather. So you also have 4 and 7. And for 4, you have 2, 5, 8. For 6, you have 0, 3, 6, 9. And for 8, you have 1, 4, 7. So counting the number of values here, we have 13. You have 3, 6, 9, 13. So number 26 is 30. Okay. Number 27. Find the number of positive integer solutions A, B of the equation 1 over A plus 1 over E is equal 1 over B is equal to 1 over 24. So positive integer solutions, which we can use later. So solution 1 over A plus 1 over B is equal to 1024 can just be expressed as B plus A over AB is equal to 1 over 24. For this one, we can just cross multiply, and you will have AB minus 24A minus 24B is equal to 0. So similar to having factored xy plus x plus y plus 1, you can also try to apply or try to factor this one. If you'll notice, you have A, B, and the variables A and B are separated here. So that means if you try to factor that, then you would have A and B separated. Here we have negative 24. So how do you get negative 24A? So you have to multiply A by negative 24 here. So same with B, so negative 24. So which means there is something missing here. Now the missing value here is negative 24 times negative 24, or just 24 squared. So you need to add 24 squared to both sides of the equation in order to factor it. So that will be a minus 24 multiplied to b minus 24 is equal to 24 squared. So just like last time, in order to get the positive integer solutions, you can just factor a minus 24, and you can just get the number of positive factors for 24 squared. So that will be, also the factors of 24 squared is 2 raised to 6 times 3 squared. So in order to get the number of positive factors, get the exponents, 6 and 2, add 1 to each of the exponents, and multiply. So you'll have 7 times 3, which is equal to 21. So there are 21 positive integer solutions for number 27. Okay. Number 28. At the moment, Jay has 3 10-peso coin, 2 5-peso coins, and 9 1-peso coins in his pocket to pay for his jeepney fare. If he picks 8 coins at random from his pocket, what is the probability that this will be enough to pay for his jeepney fare of 12? So when we say enough, 12 pesos. So there is a chance that if you pick up, let's say, let's say 2 10-peso coin, so that will be 20 pesos. So it is enough, and it will still have change, right? So what is the most efficient way of solving this one? You can just get the complement. What if it is not enough? Okay, so the the only scenario where the total value of the coins will not be enough is if you took all of the 1 peso coin. I know, not all, 8 1 peso coin. So that will just be 8 pesos. Because if one of the 1 peso coin becomes a 5 peso, so that will be 5 plus 7, which is 12, which is enough. So for this one, we are lucky because we only have one scenario. Okay, so we have 1 minus a. So the number of ways to get 8 1-peso coin will just be 9 choose 8, right? Divided by the total number of coins. We have 3 plus 2 plus 9, which is 14. 14 choose 8. Simplifying, you will get 1 minus 9 over 3003, which will give you a simplified value, which is 998 over 1001. So the answer for 28 is 998 over 1001. Okay. Number 29. Find the smallest integer a for which square root of a plus 539 plus square root of a is an integer. Okay, so a is an integer, and this expression is also an integer. So what do? We substitute. So let m be equal to square root of a. So that will be m squared is equal to a, right? And also let n be square root of a plus 539. So that will be n squared is equal to a plus 539. And if you remember, a is equal to m squared. So we established the expression n squared is equal to m squared plus 539. Okay, so for this one, since we already have that, what we can do is create a difference of two squares. So that will be n squared minus m squared is equal to 539. We can then factor n squared minus m squared into n plus m multiplied to n minus m is equal to 539, which then gives us the value m is equal to 19 and n is equal to 30. Actually, this is, I think this is not the only value for m and n. But what you can do is try to get factors of 539 and then assign them to n plus n and n minus m. Okay. Knowing that n is greater than m, then of course, n plus m should be greater than n minus m. So it will be easier for you to solve for m and n, because what you assign n plus m should be greater than n minus m. Okay. So solving for that, we found out that the smallest value for m is 19 and the smallest value for n is 30. So hence, if you try to get the value of a is equal to m squared. So you get 19 squared, which is equal to 361. So the answer for 29 is 361. Finally, number 30. Let R, S, and T be the roots of the equation 2x cubed plus 6x squared minus 3x plus 4 is equal to 0. So determine the value of the expression 1 over R minus 1 plus S minus 1 over S minus 1 plus 1 over T minus 1. Okay. So since we know that R, S, and T are the roots, and also we have this expression, what we can do, if we think that we can factor that out, or if you don't want to try to factor that one, you can just use Vieta's formula, right? So the Vieta's formula will just be something like this. If you have, okay, so if you remember Vieta's formula for quadratic, we have if you have ax squared plus bx plus c, right? Then the sum of the roots, let's say m and n, wait, I'll just write sum. The sum will just be negative b over a, while the product will be c over a. Okay. However, we are given a cubic function here. So the Vieta's formula will also be adjusted. So if you have ax cubed plus bx squared plus cx plus d, then our Vieta's formula, so if, let's say I will have to apply this one, R, S, and T. So the sum, R plus S plus T, will just be equal to negative B over A. So same. So the product, R, S, and T, will just be negative of D over A. So why is it negative? Because later, if you know the formula, the general formula, you actually have negative 1 raised to n here. So if n is even, then of course it's positive, like the quadratic expression. However, since we are cubic and the n here is 3, then of course negative 1 raised to n is a negative. So you have negative d over a. Now for the other one, so sir, what's the use of c? So that so the use of that is this one. So the sum of the product of the pairs that you can form from RS and T. So you have RS plus ST plus RT is equal to I forgot if it's negative C over A or C over A. I think we can just check later. Okay, so the solution here will just be 1 over R minus 1 plus 1 over S minus 1 plus 1 over T minus 1. Simplifying, you will get, of course, we'll just get the LCD and then try to simplify. Now, when you simplify this one, you can actually group the values in such a way that you will have RS plus RT plus ST, because of course you have RST, RT, and RS. You also have minus 2R, minus 2 multiplied to R plus S plus T, because of this one, minus T, minus T. So you have minus 2T, and for the other ones, yeah, you also have, so you have minus 2 multiplied to R plus S plus T. And then for the constant value, negative 1 times negative 1, that will be 1. So since there are 3 products here, so 1 times 3 is 3. Now for the one below, you can just simplify that as RST minus the quantity RS plus RT plus ST plus R plus S plus T minus 1. So after you simplify the second line, your goal is to create these expressions, R plus S plus T, this one and this one, so that you can substitute the values. for that you can get from Vietas. So here, note by Vietas formula, R plus S plus T is equal to -6. So as you can see, negative V over A, -6/2, which is -3. Okay, so this is actually C over A only. So R plus S plus R, S plus RT plus ST. So you have -3 over 2. And for the product RST, you have -4 over 2, which is -2. Okay, so you can just simplify that one. So hence, you have -3/2 minus 2 times -3 plus 3 divided by -2 minus negative of 3/2 plus -3 minus 1, which when simplified will give you -5/3. So the answer for question 30 is -5/3. Okay. So questions or clarifications, guys? You can now ask for questions. 30 S1, so number 16? Number 16. Okay, let me just check number 16. Wait, let me check number 16. Let me go back to number 16. Here. Oh no, wait. Where's that one? Here. Share screen, number 16 here. The cube one. Why did it become 30s plus 1? That is because when you try to get the perfect square, you will get s sub 1 quantity squared, and then you have 30 s sub 1 plus 225. So removing this one, because of course, you can subtract the two of them. So you'll be left with 30 s sub 1 plus 225. Okay. So how about the others? Any questions? How about the others? If you have questions, please type it in the chat box. If you have no questions, please type none. If you have questions, please do ask. How about the others? Okay. So if there are no more questions or clarifications, I think that's it for this session. So I hope you learned a lot this afternoon. Thank you for listening. Okay. So see you next week for session 2. Okay. So bye guys. Take care everyone. Thank you.
Goodbye and thank you po, sir.
Thank you.
Bye po. Thank you.
Thank you. Bye. Bye everyone. See you next week. Yeah. Bye. The meeting, it will be sent after uploading. Okay. You still need to upload it in the drive. So it will be sent later. Bye.